atoms with electrons in the state E2 remains there for longer period in the order of 3 into 10 to the power minus 3 milliseconds. This electronic state is called as metastable state. The number of atoms with electrons in this state E2 is said to be as N2. The number of atoms with electrons N2 in this state E2 will be increasing rapidly. At some point, N2 becomes greater than N2. This stage is called population inversion. That means number of atoms in the higher energy state is more than the number of atoms in the lower energy state. But actually, number of atoms in the lower energy state should be less than the number of atoms in the higher energy state. So there is a reversal occurred. So this is known as the inversion. So number of atoms at the higher energy state becomes more than the number of atoms in the lower energy state. This is known as the population inversion. This process in which the number of atoms with electrons N2 in higher energy state is called metastable state of an active medium is increased to a value greater than the number N1 in the ground state. That is, N2 is greater than N1 is called population inversion. How could we achieve population inversion? This is we are taking the case of ruby rod. This is the active medium and there are two mirrors. One is 100% reflecting, another one is partially reflecting. A xenon flash tube is used to excite the atoms. Xenon flash tube will produce light having wavelength of 550 nanometer or 5500 angstrom. So population inversion is achieved by the supply of sufficient and appropriate energy to the active medium from an external source. Here external source is xenon flash light. An active medium is ruby rod. Basically ruby is the combination of, it is a compound actually. It is a combination of aluminum oxide and chromium oxides. Chromium ions are readily excited. Now this process of achieving the population is in inversion is called as pumping. Here this light is used to pump the atoms at the lower energy state to the energy state E3. Now from E3 to E1 and E2 there will be spontaneous emission. From E2 to E3 to E2 the energy is very less. So this is the radiation less transition. And E2 where the number of atoms is more or lifetime of atoms is more compared to the E3, it is a metastable state. Now it is radiating energy of 694.3 nanometer. Now using this partially reflecting mirror, this light is fed back and it is stimulating the atoms at the energy state E2. These atoms will come down with releasing the matching photon. So light is amplified here by means of radiation. So this is how ruby rod will produce laser light. Optical resonator and its role. Pair of parallel mirrors, these two are parallel mirrors at two ends of the active medium. This is the active medium. To allow particular wavelengths and to suppress unintended wavelengths. Optical resonator selects some photon states and suppress other states, provides high directionality. This is the basic nature of laser light. It directs the photon back and forth from this direction to this direction, this to this. This is the partially fully reflecting mirror. So this one will reflect entire radiation. Here some light will come out and some light will reflect back. It directs the photon back and forth through the active medium and enhance the photon number by stimulated emission to get intense beam of laser light. Creating standing wave from two waves moving in opposite direction. The solid line describes a wave in moving left to right. On the right side of the figure, the superposition of the two waves is shown. Like standing wave in a string attached to fixed points at both sides. The fixed points of the standing waves are called nodes. These are the nodes. The distance between adjacent nodes is half to the wavelengths of each of the interfering waves. So when this wave is coming left to right and this dotted line coming from right to left, they will superimpose, and after the superimposition this becomes the nature at t is equal to 0. At t by 4, this is the nature, resultant wave nature. T by 2, this is the resultant wave nature. This is how we have produced nodes and antinodes, nodes and antinodes, nodes and antinodes. When this is the antinode, this one is a node, this one is a node. Node and antinode will produce. Longitudinal optical modes in laser describe standing waves along the optical axis of the laser. Standing waves are created when two waves with same frequency and amplitude are interfering while moving in opposite directions. Laser cavity is made of mirrors, as we have already seen. Laser cavity is made of mirrors at the end of the active medium. These mirrors reflect the electromagnetic radiation back to the cavity again and again to create the standing waves. The mirrors are nodes of the standing waves. The frequency of the basic longitudinal laser mode is nu1 is equal to C by 2 NL. N is the refractive index of the active medium. L is the length of the optically active medium. The frequency of M longitudinal laser mode is nu m is equal to M C by 2 NL. C represents the velocity of light. Thus, the frequency of the M longitudinal laser mode is equal to M times the frequency of the basic longitudinal laser mode. This is nu1. So nu m is equal to M nu1. The difference between adjacent longitudinal modes is equal to the frequency of the basic longitudinal modes. This is delta nu is equal to C by 2 NL.